Good morning. It's my first day back from break. My students today will be working on a unit menu, at least the students that are in my honors classes. We're working on solutions, and then my students in the college prep level are working on a simulation graphing activity that has the students kind of graph the relationships between temperature and reaction rate, and we look at particle size and reaction rate. So it's a really cool sim actually Glencoe put out. I just made the questions that go along with it. So anyway, here I go to start my day. So today, because if you notice on the unit menu, so if I scroll down here, you'll see that for this unit menu, technically, right, today is the 9th. Today we should be into colligative properties, but I know for a fact that that's not true. So I took magnesium and I reacted, yeah, it's just about gone. I took magnesium and I reacted with hydrochloric acid. Oh, this one's gone.
And that one still has a whole bunch of...
Look at this one. So this one's gone already. This one's done. And then this one's still going. Right? This one's still going. Okay. Good morning. It is Tuesday, April 10th, I think. I am headed into school now. My students today will be working on their unit menu. So that's my honors class. They'll be working on a unit menu with solutions. In particular today, I'm anticipating them getting into at least colligative properties. They have a mini lab that they will be completing, and that'll actually ask them to propose an explanation for their observations for a freezing point depression. So I have the students creating a model. I call them explanatory models because they seek to explain something. And so it's good because one of their assessments later on in the week will ask them to construct an explanatory model as well. My CP classes are working on, what are they doing? Oh, we are finishing up our unit on reaction rates. So they've had 3 opportunities at this point to engage with the material. They first constructed graphs and interpreted their data in order to explain, based on collision theory, why reaction rates will speed up or slow down depending on things like concentration, temperature, and surface area. And today they have some extra practice with that, and so they're going to be working on a worksheet. So I am going to get ready to start my day. I'm actually pulling into school now, and I will talk to you later. Good morning. So it is Wednesday. God, it seems like it's like the slowest week ever. It's still below freezing in the morning, and it's definitely causing a problem when I'm trying to get to school because, oh goodness, it's like springtime. It shouldn't feel like this right now. So today my honors class has a quiz. They are going to be quizzed on solution concentration and dilutions. That was part of their unit menu. The quiz is a little bit later than I had planned because we kind of had spring break in between. The marking period ends Friday, so that's why I wanted to kind of get one more, last assessment in. My CP kids are actually starting to work on their engineering design challenge. So I'm kind of excited because I really enjoy the engineering process, and I really enjoy giving the kids projects to do in class. And the kids, I think, like it too. It's a nice change of pace. So the students today will be learning about what engineering is, and they'll be going through and learning about the engineering design process, some of the things that they'll be participating in order to develop their prototypes and evaluate their prototypes. The project, specifically what they'll be designing, is bath fizzers or bath bombs. We call them bath fizzers in class. You can probably imagine why. But it's a great project. The kids really enjoy it, and I would say out of everything, it's not super content rich. While that is important, and there definitely is a lot of chemistry content involved in terms of reactions and reaction rates, I would say that it's more about the kids trying stuff and trying to defend their answer in terms of scientific evidence and principles. So it's going to be a busy day, and I'm just about to pull into school, so I will catch you later. Able to blog a little bit more today because I have kind of a little bit more free time. So my students in my honors class today, they took a quiz on solutions and concentration units, and today I'm moving into my engineering design challenge with my CP classes. We're going to talk specifically about what is engineering today, and I'm going to actually read them a story. So it's going to be interesting because I'm reading I'm reading them a storybook. I'll show you what the book is. So the book is one of my favorite books to kind of read with students. It's called What Do You Do with an Idea? Oop, that's the bell, so I gotta go, but I'll let you know how it goes later. Well, you're gonna learn right now. At first, I didn't think much of it. It seemed kind of strange and fragile. I didn't know what to do with it, so I just walked away from it. I acted like it didn't belong to me. But it followed me. Do you see it? See the little idea?
Is that an egg?
Did you teach a kindergarten class?
I worried. Come on, give me a sec here. I'm enjoying myself. This is something I don't usually get a chance to do with you guys.
And you're reading it so well.
Am I doing a good job? I practice.
You definitely taught a kid.
I practice. Okay.
Strange, like on my lower left side.
Oh, okay. Did you test this?
No, but it was like
Do you
a normal
want-
rate in the cold water.
Okay.
So then it would be.
I love that. I love that. That's really, really good. Really good.
I think our mind map would be.
That looks great. So you want to make sure that you include some criteria and some constraints and what's your problem. Okay, so here's your problem.
Yeah.
Awesome.
That's a
That looks
problem.
great. Okay.
Do it in like a little prince.
That sounds, yeah, whatever. I think that looks great. So I just finished my day today. The bell just rang and my students are kind of out. Today's Autism Awareness Day, so that's why I'm wearing this puzzle piece. So I think the students were actually pretty engaged with when I was reading the book about what do you do with an idea. I hope that, I think with anything in life, you get out what you put in, and what the students take away from it is really up to them. But I didn't want to tell them what to think. I wanted them to kind of just come up with their own conclusions about what to do with an idea. I will say that I felt that this is the first year that I've actually read that book to them. I did feel like when they were mind mapping that they were a little bit more engaged than they have been in the past. And so I think that that's going to make a really huge difference in basically their prototypes. One of the things that I really drove home as we were going through and doing this today is that it really doesn't matter to me whether or not their prototype is successful. Really what matters is the process that they follow. So with that, I am going to clean up. I am going to get ready for tomorrow. I have to actually go through and get my chemicals ready for them to actually start formulating their first bath bubbler. So here we go. Morning, YouTube. So today is Thursday. My students will be working on today their engineering design challenge. So yesterday was a great day. We spent a lot of time talking about the engineering process. We watched a lot of videos. GE, General Electric, actually has some really great commercials that you probably have seen, like Ideas Are Scary, and then Molly, the inventor. So we were kind of talking a little bit about that. The students spent time identifying criteria and constraints because they will be using that in their own engineering design challenge when they build their prototypes. They spent some time mind mapping. The mind mapping in particular was most interesting to me because they had to develop an improvement for my bath bubbler prototype. So they did a really nice job. They were very thorough when I was looking at them. I'll post some different things that they were doing with that. But for the most part, it was great. My honor students were working on, well, they took a quiz. They took a quiz on dilutions and concentration units. For the most part, they did well. Mullally always tend to do kilograms of solution instead of kilograms of solvent. So there was a lot of correction with that. But I do partial credit, so it really doesn't make that huge of a difference. They lose a point here and there, but the end of the marking period is really coming to a close. So the end of the marking period is Friday. And then that's pretty much it. So today we are going to be kind of working on our research aspect with the engineering design challenge, and then my honor students are finishing up with colligative properties. This is the last day of their unit menu. So with that, I am going to head into school, and I will hopefully catch up with you guys later. Hi. So it is the end of the day on Thursday. I totally forgot to vlog, so I thought I'd do it on the way home. Today was a good day. My honor students finished up their unit menu. They did a really great job with that. One thing I really like about the unit menu, I was really thinking about this, what value does this add to the class besides just teaching the students chemistry? And that's what I always try to go for whenever I'm designing any kind of activity or project. So for this, I kind of feel like the unit menus allow the students to pace themselves and give them some idea of time management. One thing it also does is it allows the students to be able to pick the activities in which they learn the content, and then let's say, for example, they pick an activity that maybe doesn't jive too well with them, maybe they're not understanding the content, they can go back and pick another activity to do. So that's what I really, really like about the unit menu. It's been working really well, and the students have really taken a ton of ownership over their own learning as a result. So it's really become quite a great staple in my classroom. This is probably the 5th one I think I've done, but I really, really like it. My CP students finished up their, I guess they were working on their engineering design challenge, but it was their first document. So they were working on their mind mapping, and then they also had an opportunity to conduct some research. The research document is actually fairly simple. Basically, I give them the ingredients that I use to make my bath bomb, and the students research the purpose of every single ingredient in the bath bomb. And there are some questions in there. They'll say, for example, cornstarch is a filler, and I'll say to them, well, what does that mean? Or they'll say, the citric acid and baking soda react together, and then I'll say, well, what's the reaction? So the issue that I'm finding with the students completing that is that they're not being specific enough in their research documentation. So, but that's an easy fix. That's something I could just mention, and they're all making pretty much the same mistake. So it's definitely not too bad. They're doing a pretty good job with it. I really emphasize this year the importance of making sure that they spend a lot of time in the research, because that ultimately will help them have a better prototype. So overall, it was a great day. I'm actually on my way home. It's about 4 o'clock, and kind of an early day for me. Usually I stay much later, but it was a pretty good day. So that's about it. One more day, Friday, guys, coming soon. Morning. So I'm on my way to school. It looks definitely dark this morning because I'm heading in a little bit earlier because I have to set up the chemicals and whatnot for the students to do their engineering design challenge. So hopefully today we should have students building and testing their prototypes. I'm very excited. That's in my CP classes. My honors class today will be working on a study guide because they have their test on Monday, actually, on solutions. I wasn't too far behind with my unit menu, but the unit menu took place over the course of spring break, so one of the days we actually had a half day, so that's why we were a little bit behind. So, but overall, my estimation for all the activities, not too bad. And the other honors teacher is also testing on the same day, so I still made it, so we're good. So anyway, I am going to be pulling into school in a little bit, but I'll let you know how the engineering design challenge goes with their prototypes. Here we go. almost almost 1:15. I am just about done with my classes. I have one more class to go. My honor students today, as I mentioned in the car this morning, they were working on a study guide. They worked really hard on it. They had a hard time with one question that I put on there because it was framed in a different way that I've asked before. So isn't it funny? As soon as you change the wording, it's like things change, so quickly. But regardless, the students still worked through it, so they actually did a really good job. So those students, they're ready for their test, which is going to be on Monday. My CP classes were working on their prototype today. It was pretty good for the most part. I would say that the students needed a little bit more guidance than I was anticipating, but overall it was pretty good. The students are all doing it in like a Google Doc, so I was able to kind of see who made what edits, and then I was also able to see their research, so I was able to make comments and use that comment feature in order to help them. And so that made a pretty, big difference in terms of the things that they were finding. So they kept saying, for example, like the baking soda and the citric acid are reacting together, but then they weren't telling me like what the reaction was. So they needed a little bit more, I think, guidance with that. And I finally said, like in the Google Doc, I was like, what is the reaction? But other than that, they did good. They pretty much, I'll show you, I have a couple of samples in the oven, actually, that the kids are working on. You like my new Poggle shirt? Isn't it cool? I just got it. And on the back it says, keep calm and Poggle on. Oh, look at this. So this is their first prototype. So this is one set, and this is another. Okay. And then up top here, this group did something very interesting. So they wanted to make bath bubblers that were made out of salicylic acid. So this is theirs. And then these are the ones that kind of aren't looking so hot. So it's their first prototype, so naturally it's not going to be perfect. They actually have definitely some more work to do, but I think that usually the second prototype batch is much better than the first if they learn from their mistakes, so they have to go back and they have to take a look at their formulation, and that'll help them to ultimately be able to decide on what they need to change and what they can improve upon. So other than that, that's pretty much what's going on. I am going to hopefully get out of here as soon as possible after school today. I have to help a coworker with some technology stuff, but then I'm off for the weekend. So hopefully you're having a great weekend. Thank you so much for watching my week.